farm system. I guess that.
Does anybody in here have bad memories about inverses?
Pretty much. I think I kind of forgot.
Well, we're going to form good ones then.
I have bad memory.
Inverses are our friends.
Fish are friends.
Not food. Yeah, don't eat your paper. Okay. Lots of ways to do this. Let's start easy. If I give you some function in a table,
Oh, I remember.
right? The question is, for this function, what would the inverse function be? Yeah, so the inverse is just switch the x's and the y's. Okay. So all you have to remember on inverses is switch x and y. Okay, no matter what you're given, a table or a function or a graph. Okay, so if you switch the x's and y's, then solve. That's it. Okay, so a inverse, we switch x and y. Okay, that's all you got to remember. And then, if necessary, do more work algebraically. And I know you know the algebra, so let's take a look at a really easy one. Calculate the inverse.
Hello.
You alright, Obed?
Huh? We're not sure anymore.
Do you want me to do a linear one first? Or
Yes. Yes.
Oh, okay. I can do a quadratic too, but well, you have to reproduce quadratics, so I'll show you. Okay, so y equals 3x plus 5. Algebraically, again, calculating inverses. What do you do?
Switch x.
Okay, fine. Be that way. Being aware this can also be written like this. Right? It's the same thing. Right? Switch the x and y. Now what?
Solve it. Make it.
That's it. Solve for y. Okay? So get that big general theme in your head, switching x's and y's, and then if you need to, solve for y. Okay, so first step, we want to isolate. So what's the first step?
Subtract 5.
You're like, why are you asking me this? This is elementary. Right?
Yeah.
And then? You're like, no, not really. But I'm going to say yes just to satisfy my teacher. Yeah. Okay, so y is x minus 5 over 3. Okay. To be totally proper, we would write that means inverse. So if you hear me say f inverse of x, that's what I
Oh,
mean.
I forgot to solve for x.
Okay.
Wait.
Solve for y.
Never mind.
Can I rewrite this too?
Yeah.
To make it more slope-intercept friendly. 1/3 x minus 5/3. You put the 3 in both terms, right? Okay. So, all right. So there's a pretty straightforward algebraic. Let's look at the graph of the two.
Does it matter which way we put it?
Which way?
Yeah.
What do you mean, which way? I don't understand your
Do we
question.
have to simplify it?
Do you have to write it like this?
Yeah, that and then the other one?
You just need to-
Oh, you don't have to do this.
Okay.
This is definitely preferred, because all I have here right now is a function and another function. But what this tells me is that these two are related to each other, right? They are inverses. So there is some information contained in this that we want to get out there to people. Okay, it's just being detailed, right? Okay, so let's graph that one. Nope, wrong dot. Okay. And let's graph that one. 5/3. Somewhere in that neighborhood, right? And up 1/3. Okay. That's not perfect, but it'll do. Do you notice anything?
One line's red.
Wow.
The other one's black.
In the same one.
Well, they're both aligned, yeah, okay. So we've determined color and shape. I'm making fun of
One
you.
slope is 1/3 and the other's 3/1.
Ah, they are not perpendicular, right? Because it's not negated, but that is one of the relationships you'll see. The slopes are reciprocals. Okay. What is the x-intercept of the red line?
1, 2, 3, 5.
Yeah, the x-intercept is 5. What's the y-intercept of the black?
5.
Ooh. Right. That's because this point is 0, 5, right? This point is 5, 0. Hey, look at that. Switch the x's and the y's. Where do they cross?
Somewhere on the graph.
This is where x equals the y value. Right? 'Cause if you're switching them, it's not perfect, but -2, -2. Anywhere there's a matching x value, that's where they will cross. In fact, that's the line y equals x. Inverses are a reflection over that line. That was dumb. Sorry. Okay, so if you reflect either line over y equals x, you have the inverse. So if you're graphing only, that's one way to calculate it too. Right? You can switch the x's and y points, right? Like this would be -5/3, right? Right there. This would also be -5/3. Okay, we're reflecting. So, a couple ways to tackle the graphs, okay, versus the equations. Okay, are we good with that? All right, so we've seen a table, a function, and a graph, right? So, that's basically the 3 ways that I'll ask you to know how to calculate an inverse.
So when you say calculate an inverse, when you give us the actual y value?
So I'll either give you a table or a function or a graph. It says, what is the inverse of f? You just match accordingly. Let me show you a little more difficult one. I have one in here, if not, we can make it up. Yeah. Okay. What's the inverse of that function?
It's mine. Square root of X minus.
Yeah, okay, you're trying to do it in your head, which is fine. That's fine. I struggle with that. So I always write my work down. That way we can see errors, right? Yeah.
I don't think so.
You don't think so?
No, because whenever you ask me for like an answer or construction, you usually do it in your head, and I'm like, oh, well, you asked me then.
I don't remember that.
You always do it.
Always. I always do it. I never show my work in the wood shop. Ever.
Never.
He's not even asking.
You're full of crap.
You write
Okay.
it down, but then you just give the.
All right, so
answer.
the challenge here would be to solve that for y, right? It's the same process as the last one, but there's a square in there.
So you have to
No, please do not FOIL that because it makes it impossible.
square root it.
You just add 5 as always, right? We're getting rid of that. Okay, so I've moved the -5 or the -5. Can I tackle the square root pretty easily now? Yeah, I square root it. Okay, so just be careful here because when you square root a squared, you are in fact, you have to consider the positive and the negative case.
And this is why.
Because we can have a negative squared or a positive squared and it gives us the same answer, right? So we still have to consider both those cases here. And then -3. Some people write it like this. Okay. I'm not going to write F inverse yet. Okay, so don't write that yet. For a reason. Can you graph those two? Yeah, let me, let's just look at that real quick. Because it's kind of screwed with you a little bit. Okay, what's the shift here?
John 5.
Down 5?
Left.
Left 3. Still the same x squared, right? So same one, we just moved it. Okay. I get it.
Oh, yeah.
Okay. What are my movements here? Left 5, down 3. Which way is it going to open? Yeah. Okay, so we open to the right. So quadratics have, when we calculate the inverse, it actually changes it to an open right or left. Okay. If this function were down, frowny face, it would go left. So, and yeah, just keep in mind that reflection over this line. So you can see how those dots are reflected. Or again, switch them. If this is -3, 5, -3, -5, and this is -5, -3, right? So, are you okay with the algebra of the graph? Okay. here's the big question. Is f a function? Yes or no? Does it pass the vertical line test? F does? Okay, f is a function. Okay. But is this a function? Why not? It does not pass the vertical line test. Okay, so
What would that call? Like, is that what the blue one is?
inverse of f is not a function. Okay. What test could I use to determine if the inverse is a function without graphing it? Google. Google's not a test. It's a weak way to find an answer. If I horizontal line test the original function, does it pass the horizontal line test? So is the inverse a function? No.
How do you use it?
So if the original function does not pass the horizontal line test,
How do you solve that? without
the
graphing?
inverse is not a function.
How do you find the horizontal line?
Well, it's quadratic. You know that it goes like this. Does it pass twice if you draw a horizontal line? Yeah.
If it did it, how do you know?
So let's look at the linear function. Does the original function pass the horizontal line test? Yep. So is the inverse a function? It does. Okay.
So like, if the parabola was above the x-axis moving upwards, does that go down?
It doesn't matter positioning. It's a quadratic. It will not pass the horizontal line test. Okay. So if f passes the horizontal line test, f inverse is a function. Can you see that green? That is awful. Right, so this is a handy way to determine if the inverse is a function or not. So did I write this as f inverse? I did not, for a reason, because it's not a function. Okay, that's why I didn't write f inverse. Mr. Jansen.
Does that apply to all functions?
Yeah,
That's his
it's a
problem.
universal way. I keep waiting for him to say that. You never does, so there you go. That's that. Yeah, so. No. Okay, I'm done. You have any questions? You hear that? I heard what you said. Yeah, that. I didn't hear what you said.
Oh, you said,
I tend to ignore Brandon.
oh.
It's a very nice coping mechanism so that I don't get angry. Okay.
I'll ignore it a lot.
Oh, you told me that story was
All right, yeah, oh, it looks like a really long assignment, doesn't it?
Yeah.
Mother of pearl. It's not that big of a deal because I pick and choose based on what you need to know for the future math you're going to do. It's no more than usual. It's just individual numbers. Okay, so don't be afraid.